Hello everyone, welcome back to Dr. Ghosh's MEEP channel. This particular lecture is the glimpse of Student Mentorship Activity 2023. I, Dr. Deepankar Ghosh, Associate Professor and PI in Microbial Engineering and Algal Biotechnology Laboratory, Department of Biosciences, JIS University, Kolkata, will deliver this lecture. The lecture will be focused on the current advances on the biomedical waste recycling and its bioremediation. So let's get started. Before we get into the topic, first of all, I would like to acknowledge to all my Meebroomies, especially Atreyi and Rajarshi, for their immense support to complete or to come up with this assignment as a student mentorship activity 2023. So first question that would come in our mind, that is how you can able to define biomedical waste. So biomedical waste is defined as the waste generated by a medical procedure or practice at the healthcare or research facility units or the clinical laboratories. Medical waste has increased in last 3 years as a result of different pandemic and outbreaks, including COVID-19. This condition is expected to exacerbate due to the growing healthcare market and aging population that would pose the health threats to the public by environmental footprint. So to alleviate this impact, there is an urgent need for medical waste to be get recycled back. This particular lecture highlights there are certain drawbacks of current disposal methods, the potential of the medical waste reuse and recycling applications, emphasizing different processes, their uses materials, chemistry involved in each and every approaches. So the issue of the biomedical waste management has assumed great significance in recent times, particularly in view of the rapid upsurge of the HIV infection. So medical waste is usually divided into two categories: hazardous waste, including biological, chemical, radioactive, and or physical footprint. Whereas in non-hazardous waste material, constituting about 85% of the waste which are being generated from the healthcare activities that are similar to domestic waste. Improper medical waste handling, disposal may impose health risk on the healthcare workers. The mainly occurs through the transmission of the infectious or the multi-drug resistance microbial regime, toxic exposure to chemicals, pharmaceutical waste, and the release of air pollutants. Soaring medical waste production as a result of COVID-19 and so many other pandemic is expected to be executable, perpetuated by the projected growth of emerging healthcare sectors and the aging population, posing environmental hazards, causing illness in a significant number of communities. Overall, the environmental impact and the health risks which have been associated with the medical waste as well as the shortcoming of the current disposal approaches have increased the demand of recycling establishment and reusability strategy to be get established as a part of waste management, biomedical waste recycling. So there are different types of biomedical waste which are being characterized or categorized or clarified like this way. So category 1, which includes the human anatomical waste. Category 2 includes animal waste. Category 3 considers microbiology and biotechnology laboratory-based waste. Category 4, the waste from the sharps. Category 5 include the discarded medicine or the cytotoxic drug after uses. Category 6 includes the soil waste. Category 7 includes the solid waste, biochemical waste. Category 8 includes the liquid biomedical waste. Category 9 includes incinerated ash. And finally, Category 7 considers the chemical, biochemical wastes materials. Then what are the different harmful effects of poorly managed biochemical or biomedical waste if they are dumped out? So biomedical waste, when not disposed properly, can pose serious risk to society and also in the environmental ecosystem through the air emission, contamination of water, and physical contact. So improper disposal refers to open dumping, unrestrained burning, improper handling of the waste during generation, collection, storage, transport, even during the treatment procedure. The improper handling involves unsafe procedure followed during handling of the waste, likely without wearing protective equipment, poor storage, transporting manually for longer distances, uncovered or unpacked containers instead of puncture-proof bag. So infection which are being associated with different types of waste. So these are the different organisms which mentioned in the three different one column. Disease cause which mentioned in the second, and the third column related waste material could be generated. So it was quite interesting to see it. Then what are the legislation or what are the legislative activities or policies has been established or procured to combat with this issue? So recognizing the deadliest nature of the biomedical waste, the government and the Pollution Control Board, under the guideline of the Ministry of Environment and Forest, MOEF, has been established. The MOEF has promptly designed and issued guideline to the hospital to ensure a proper and safe disposal of the biomedical waste after their uses. So biomedical waste management and handling rule has been established in 1998, and that came into effect. In 2016, new guideline or the amended guideline for handling biomedical waste were released by Ministry of Environment, Forest and Climate Change. So these are the certain alterations or the upgradation has been happening between the MOF and the newly come rule from the Ministry of Environment and Forest Climate. Then how you are going to segregate the biomedical waste? Biomedical waste management is of the prejudicial impact because the biomedical waste can harmfully affect the health, leading to serious implication to the people who get in touch with it. Segregation, storage, safe disposal of the waste is very crucial to the effective managerial skill or management effort of the biomedical waste in the workplace. Segregation of waste plays a chief role for enhanced biomedical waste management. It is imperative to downregulate or reduce the volume of infectious waste, or else the quantum of the waste will be beyond the control of management. The waste is segregated, separated according to the various color of coding system. We are quite familiar with this kind of garbage can in the local areas or in the locality. Quite familiar like that, but these are the specific indication for each and every colored container that will allow to collect the waste. So these are the biomedical waste management categorization that will allow to carry out the perfect or near to be perfect segregation of the biomedical waste which are actually get released from the hospital. So usually the green color waste box for the kitchen waste or the proper tissue and water bottle and can, which is usually disposed of by incineration, secure the landfilling. In case of infectious plastic or syringe or gloves or plastic waste, which are also called biomedical waste, they can be get autoclaving, they can reduce their disposal and secure the landfilling. Final step. Infected waste like soil or the astronomical or the chemical liquids, cytotoxic chemicals, laboratory waste, expired or discarded medicine, they usually go for the plasma pyrolysis or incineration for the as a disposal procedure, and finally it will go for the deep burial. For the glassware, which are infected with the biomedical tissues or the cells, so usually antibiotic vials, the metallic implants, the glassware material having a cytotoxic impact. Usually they go for autoclaving, and then they will go for the proper recycler unit that is established, or they are the part of the recycling process. And finally, the contaminated stuff like the sharp needles or the cut glasses, they will go for autoclaving, and then finally go for the sharp. So these are the common treatment facility which are being applied by different statutory bodies that will allow to reduce or that can able to establish a proper segregation of the biomedical waste before it will go for the recycling process. Now we will talk about the treatment and the disposal of the biomedical waste. Biomedical waste treatment refers to the procedure to eliminate the harmful effect of the waste. There are numerous treatment options which maximize the safety during management. So different environmental hazard can be get reduced by using different techniques for the disposal to get recycled, like incineration, autoclaving, irradiation, chemical treatment. So incineration is the treatment process which is used to transfer the pathological or pharmaceutical waste into ash, flue gases and heat. Functioning temperature for incineration should be in the range of 800 to 1400 degrees Celsius. It reduces the bulk waste by 90 to 95% and thus reduces the harmful effect of the surroundings. Secondly is autoclaving. It is a method of stream sterilization. As we know, very familiar in our laboratory, like you have to go for the steam heat or it's a moist heat technique where you have to attain the 121 degrees Celsius temperature, 15 psi pressure, and that condition will be retained with all the waste for 20 to 30 minutes. So this action is applied to inactivate the contagious agents and to get sterilized the apparatus used in the clinical services for reusability. It is less expensive and carries no recognized health impacts. Finally, the chemical treatment. This treatment is used to decontaminate the liquid waste. So this can be disposed of nearby. It makes use of the number of techniques such as oxidation, reduction, precipitation, pH neutralization to transform waste, especially biomedical waste, into the less dangerous substances or environmentally benign substances before it will get disposed of. Irradiation. These methods are at the present being used in the waste treatment procedure, which includes the gamma, electron beam, ultraviolet X-ray. Irradiation sterilization waste is a sealed off chamber by uncovering it into a radioactive cobalt-60, which gives us gamma rays that is lethal to the microorganism. Due to have a bactericid lacking, it is very costly associated to other method, and it is a protection must be taken to guard the worker for detrimental effect, side effect of the radiation such as cancer, radiation sickness, or even death. Finally, disposal of the biomedical waste. So land disposal is usually employed for remediation of the waste which is decontaminated by appropriate treatment approaches. The technique is generally used in developing countries. Landfills should be conducted at the place where the groundwater level is low. So radioactive waste are commonly dumped in the ocean far away from the human inhabitations. So these are the different methods of disposal of the biomedical waste and their segregation based on the different categories, the categories in the waste that we had discussed in the previous few slides, and what are the different treatment procedures. It's a nutshell or summarization. You can easily read and go through and get information out. So these are the summarization, how it will make an environmental benefit, financial benefit, and public health security if proper recycling and reusability can be attained by the primary recycling or by secondary mechanical recycling approaches for different rounds or different classes of medical waste which are being generated in regular basis. And we have already discussed how you can able to go for the treatment, recovery of the biomedical waste by different processes. You can go for thermal treatment, chemical treatment, radiation treatment, biological treatment, even mechanical treatment can also be getting. So now we come to a conclusion. Biomedical waste should be classified according to their source, typology, risk factor associated with their handling, storage, and ultimate disposal. The segregation of the waste at source is a key step, and reduction, reuse, and recycle should be considered in proper perspective. Scientifically managed growing quantity of biomedical waste that can go beyond the past practices. That is another important rising issue. So these are the references for the further reading. If you are highly interested, you can go on through these particular review links. So we have come to an end. Thank you very much for your great attention, your patience to listen and enlighten yourself. Thank you very much.